The binomial theorem is used to expand binomials. A binomial is something in the form of x plus a to a power n. Normally, whenever I've run into a binomial, I've just used the FOIL method and multiplied it out. So for x plus a squared or x plus a to the third, I just do x plus a times x plus a times x plus a. But as n gets larger and larger, that's going to take more and more time. If I have x plus a to the 15th, then that's going to take me quite a bit of time in paper. So the binomial theorem gives me an easy way to get the coefficients for a particular binomial expansion. So as I know already, the expansion of binomials follows Pascal's triangle, this pattern of numbers. So when n is equal to 0, x plus a times n, I'm going to get 1, just the constant. Anything raised to the 0 power will be 1. N is equal to 1, x plus a to the first power is just x plus a, so each one is going to be 1, the coefficients. So what these numbers are just the coefficients of the different powers. So this is x, this is the constant. This is x squared, this is x, this is the constant. This is x cubed, x squared, x constant. X to the fourth, x cubed, x squared, x constant. And these are the coefficients that would go in front of them if this were x plus 1. Or x plus a, it's the same. It's just assuming that everything was as simple as possible. That's the pattern it follows. So what the binomial theorem does is it gives me these different coefficients. I can find all of the coefficients I want for a particular n, or I can just get one. This is the notation for the binomial theorem, and it's read as n taken at time j. N being the power of the binomial, and j being which coefficient I want. So if I break down Pascal's triangle, this is really what's going on. These different, let's say, levels of this pyramid or triangle are the powers n. And as I go across them horizontally, these are the different time j's. So for the first coefficient of the highest power, it starts at 0, and then it goes 1, 2, 3, 4, all the way to however many n is. So n taken at time j, that is looking for the power and then whichever coefficient I want. If I want the one for, let's say, n was 5, and I'm looking for the x to the fourth coefficient, then I would put n5, j1. And this is Pascal's triangle redrawn with the coefficients for the n and j already put in there. And this is just to show what these different values are going to give. So if I put 0 and 0 in there, it's going to give me this coefficient. If I put 3, 1 in there, then it's going to give me this coefficient. So see how that works. And what this formula does is just gives me the coefficients, and this is just the simple way of writing it. So when I evaluate 3, 1, it's going to give me 3. If I evaluate 4, 0, I'm going to get 1. If I evaluate 4, 1, I'm going to get 4. 4, 2, I'm going to get 6. 4, 3, get 4. 4, 4, I'll get 1. So that is what it is in a nutshell. And I guess I should go ahead and look at the standard form of it. This is really what's going on. I have x plus a to the n, and what it's doing essentially is giving me that particular polynomial, and I can write it out like this. N taken at time 0 will give me x to the n, and it's important here to know that I just substitute x and a in for these different coefficient values. And then as well, let's just look at it from the beginning. I go down and I start with n, and then I go 0, 1, 2, 3, 4, all the way till I run out until j is equal to n, basically. And for the coefficient values that I'm also multiplying by, I start with x to the n, and then as I start going to the right, x to the n will decrease by 1 power, and then the a will increase by 1 power, all the way until x is 0 and a is equal to n. And that is what this standard form is saying. So if I have something like 2x plus 5, and I want to write this in nj notation, and I'm not going to evaluate it. I'm not going to go ahead and do that. I'm just going to write it out this way. So nj, n in this case, I'll do 3. n in this case is 3. So if I want to write the polynomial out in binomial form, 3, 0, x to the n. So x is 2x cubed plus 3, 1. And now x is going to decrease by 1 power, so I'm going to have 2x squared. And then a will start to increase, so now I'll have just a. A is 5. 5. Now x decreases by another power, and a increases by another power. So it's 2x squared here, now it's just 2x, and now a is 5 squared. And then finally I have 3, 3. And then x will be to the 0 power, so it'll just be 1, so I'm just not going to write it there. And then 5 will be to the third. And then if I want these coefficient values, then I would just plug these values into this formula, and then they would give me 1, 3, 3, and 1. So if I want to, I can just replace all these. So 1, 3, 3, 1. And it's important to note that I don't have to memorize this triangle. That's what this formula is for. It gives me all of these different numbers. That's the whole point of it. But this pyramid's easy to get anyways. I mean, if you really wanted to, it's just triangular addition. So there's nothing in here. 1 and 1. 1 plus 1 is equal to 2. And then the 1s keep going all the way down the side, because there's nothing to add here. It'd be triangular. So I got 0 and 1. 0 and 1. 1 plus 2 is 3. 2 plus 1 is 3. And then 1 goes down. So the 1 is, don't worry about that. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1. 1 plus 4 is 5. 4 plus 6, 10. 4 plus 4, or 4 plus 6 is 10. That's what I meant. 4 plus 1 is 5, etc. So that's pretty simple. And that's all there is to binomial theorem. It looks really complicated, but it's in fact really, really easy.